Okay, let's give this a shot. So I'm going to try to do this in one take, so I don't have to edit anything. But I wanted to, I've been waiting on parts for the better part of 2 weeks, given we had about 22 inches of snow over about a 3-day period. So for Arkansas, that is about twice as much as we get in a decade. So we've been dealing with that, and because of that, I was making a lot of progress on this project, but then the snow came. So I did get to use my tractor. I did get to use this system, which worked very well, both with the 20-25R pump and the 10-25R pump. I think the surprising part to me was the 10-25R pump really did a lot better than I expected. For those of you following along, the concept of taking, what is about 3.5 gallons a minute that's going to the steering and taking 1.5 gallons to 2 gallons of that a minute and putting it on the implement side really does make a difference. Now, that said, it makes a difference at RPMs starting around 2,000. You see a significant bump at 2,500, and at wide open throttle, it's really noticeable and noticeably faster. I don't know if the people following along, if you've seen, I think GoodWorks Tractors did it, and if I remember, I'll link it below. He did a comparison, Courtney did a comparison with the Kubota, I think at the time it was the 23D backhoe loader with the 10-25R, and it looked bad because it really wasn't bad, but it looked that way because basically at idle, the Kubota didn't have any flow to the implement. And I think after all of the things I've done in this project, I understand that now. They're using probably a similar system to John Deere. The exception is for them, I think they're using a priority flow divider, which means it has to satisfy the fluid to the steering circuit before it gets any fluid to the implement circuit. And that's why I think I've heard people say recommendations of not running it at the lower level. I don't think that's going to hurt anything because the pump has always got fluid. You're just not going to see any fluid flowing through that implement circuit unless you have enough RPM. So with the John Deere, this is the key to separating a single positive displacement, fixed displacement pump into 2 separate flows. And if you see here, the input of this, and this is not actually factory. I have used this on a different part of the setup, so I'll put one of these on. This is just a Parker Hannifin connection, but it's exactly the same. So what happens, and this is how you would see in the configuration if you guys have looked closely, there's a connecting wire here. This that goes to the PTO switch. This is what actuates your PTO. And the way it does that, there are 2 ports here, and you'd have to see the tractor side, but this one has an O-ring. And what this is a minimum pressure. So instead of a pressure relief valve that actually actuates when you have enough pressure or too much pressure, so 3,000 PSI, or if you think about the one on the John Deere SUV from the factory is set up somewhere around 1,900 to 2,100. This is the opposite of that. This says you have to, before it works, you have to have at least 200 PSI, and that it wants to see that much pressure running through this PTO switch or flow divider, depending on where you look. If that is satisfied, and there's a few other things, do you have everything in the right position as to whether or not it'll actuate this? But when it does, pressure will come into this port here, which is it's on the side of the transaxle, and that's what allows the PTO to engage. So if you think about that, this is a lot of stuff in a single block here. It's nicely designed, I would say. But I do think it's undersized based on, you know, what the tractor puts out. So all that to say, you know, you have a feed, it's a 1/2 inch feed that comes directly from the existing pump. So for those of you not familiar with hydraulics, this is called an O-ring face seal, or ORFS. And they measure these in what they call dash sizes. So a dash one would be 1/16 of an inch. So it is standard measurements, and this is a -8. So 8/16 is 1/2. On this side, and I'll show it to you in a minute, is an O-ring boss. Same thing on here. You have O-ring boss in here. These are -6. And to 2 O-ring face seals, these are -6 as well. So while I had this off, I needed to put a different fitting on here. So I wanted to take the opportunity to show you all what's here. And I've already loosened these. So in order to switch this out, and you'll see how this works in a second, you actually have to take this PTO switch off. And this is just it just reacts, it's a solenoid that reacts to voltage. And I don't know what the voltages are, but you can probably look at the technical manual to decide and figure out how to test it. But you know, it's pretty simple. Try not to shake the camera too hard. Pretty simple here. You know, you get that actuation, and this, I don't know if it moves in or out, or if it allows flow exactly what it does, but that's the actuator here. So you have to take that off. And all you see in here is just, you know, a spot for that. Now, typically, as you see, these, you know, the pressure will be between these 2 O-rings here. And make sure to chip an O-ring. And there's a port for oil here that comes in at the high side, which is right here. And then towards the inside, it's probably not something that you can see on this camera, but there's a port, and that most likely goes down to this one. I think this one probably supplies oil there. So with this, and I just have this finger tight because I just put it on there, you know, it screws in. Again, this is an O-ring boss, so you'll see it listed as an SAE fitting. What it has is an O-ring at the top of it. I like these a lot. I'm more of a fan of the O-ring fittings because there's basically any fitting you can think of out there. There's probably many I haven't even heard of yet. But O-rings, you know, you could make the argument that they can fail, and that is true. But it actually makes for a very neat fitting. So when you tighten something on, you saw that when this was tightened down, it went all the way into this. If you use pipe thread, you know, you're basically going to go down to the taper, so you have a little bit of excess pipe thread on the outside. JIC requires the flaring, which JIC I think work fine, and you see that in a lot of applications. But this is O-ring boss, and this right here does move. So it allows you to make sure that you can position this in any way that you want. You can see how much movement you have here, so you can bring this down, and it's still going. That O-ring seats here, so you're still going to get that tight seal, and you'll have the ability to move this wherever you want. So I'll try to show you this, but I mean, all of these hydraulic blocks, I mean, I've looked at so many over the past few months. They're very kind of rudimentary. You know, you've got your threads here, and then you've got a port, and that port is roughly the size of this. It's probably just a little bit smaller in this case. I do think with the testing I've done so far that this is probably the biggest bottleneck in the system. I'm not sure why, because the block seems big enough. I'm not sure if it's because it's too many things. Actually, I'll try to show you in a bit. The ports that feed these seem extremely small to me. So, but anyway, that's this that you can take off. And what size is this here? That's close enough. So these are just straight O-ring boss to O-ring face seal. They're both -6. Just show you what these are. So there's your O-ring. This snugs down, and you don't have to crank these things down, or these. The O-ring does a lot for you there. This one might be a little bit tighter. Ooh, I'm trying to shake the camera. So I'll pull this off. And you can, if I don't know if you can see this at all, but what you actually see is this spool that I'm about to take out and show you. But those are the holes that come through. I think I have this finger tight. We'll see. It's 15/16. So, yep, I have enough that I can turn it off. Pull it off here. Maybe I should let's see if we can take that thing off and show you what that looks like. This is the proportional spool, and effectively, and I don't know if I can show you this, with inside here you can see that this slides. So what happens is oil, hydraulic oil comes into here, and then it's hard to see, but on the side here it spills in, and when it comes in, it comes into the middle here, and then and it says this in the technical manual. You'll get, if you look at tractor data and you look at a few different things, you might get some conflicting ratios of what the fluid is, but everything that I've read that I trust, like the technical manual, that says basically it splits 50-50. And effectively how these work, and you can go on YouTube and find other situations, but this, or other graphics that show you what happens. This is this is for the implements, and this is for the steering. And this is sitting in behind it. And as fluid comes in, and the steering probably rarely has much pressure. The pressure relief valve of the orbital control, which is the thing the steering wheel is connected to, is like 1,000 PSI. So you're really never gonna run between this and the steering, you're never really gonna run more than 1,000 PSI, or it's gonna bleed off to the tank. On this side though, this is gonna be, this pressure is going to be determined on your SCV for your loader, which comes factory 2200-ish. Some of us have been known to turn it up to around 3,000. And your backhoe. I don't know exactly what the backhoe is set at. I don't have the tech manual for that, but I suspect it's higher than 2200. It's probably not quite 3,000. But effectively, if you had, typically lower pressure here, and you put a load on your loader, and say it goes up to 3,000, what effectively happens is, like all fluids, you're going to go to path of least resistance. So if you didn't compensate this, then the fluid would pressurize into here. It would all go this direction, and none of it would go this direction. What happens when it senses a difference in pressure, this will move down to restrict flow to the steering circuit until it can equalize the flow between the two. So you've got, 3,000 PSI at, 2 gallons a minute, say 3 gallons a minute, and then, this is going to push down until you get about 2 gallons per minute on this side. So if it may have to go very small, but it'll do that to the degree that it can compensate for that. So again, that's really why on the John Deere, you're always going to see fluid going to both circuits. But this is part of the key to changing effectively the plumbing, so that this is no longer a restriction point, and we can actually get any excess flow to the implements. That's where we want to use most of our flow. And if you think about looking at the cylinder on the front of the tractor, the fact that it would need 3.5 gallons per minute doesn't make sense. The ram is not even probably an inch. It doesn't have a very long stroke. So in my test, I've turned it down. I don't have a hydraulic flow meter yet. I hope to have one soon. They're very expensive, and so just trying to hold off, but I think I want to make sure I have one, just so I can understand like how much flow, because some of this is theoretical. With some of the applications that I'm going, they say that the lowest is 2 gallons per minute. I've scoured tractordata.com for different subcompact tractors to see what kind of fluid volumes they're sending to their steering cylinders, and I think the lowest one I've seen is on a 25 horse New Holland, and it had about 1.5 gallons per minute. Kubota really doesn't tell you how many gallons per minute. I haven't run across any of the BX series. I mean, I'm sure some of the other ones kind of tell you, but to me it wasn't really clear for some of the BX series. Maybe I didn't look hard enough. So this is the pressure valve. Again, this is enlisted in the manual as a minimum pressure valve, and I don't know if you'll be able to see that or not, but there's a port at the very bottom and a port over kind of to the side. And then this right here, I think actually is a port between the two. So I can't say I know exactly how this thing works. This is the only minimum pressure valve that I've come across. So I know that within the technical manual, it tells you that, hey, you've got to have a certain amount of pressure before this works. I also know that, some of the people in the forums, and I have to tell you, I really appreciate all the comments and feedback and questions, because, sometimes maybe it's a question I've answered, maybe it hasn't been, trying to be as thorough and giving as much information as possible on this as I'm learning myself. But, asking those questions does make me think again about certain things. So one of the questions that came up was, could you just get a new proportional valve? And I think my guess is if you go out and look at all the different flow dividing valves out there, for the most part, I think 95 or plus percent are basically a 50-50 split, which makes sense because, in most applications, especially, not a mobile application like a tractor, you can just kind of throw, a gallons per minute at it. And that's really kind of what John Deere's done, I think. I think that they said, look, they have designed a spool that would allow 30% here and 70% here, sure. But I think that probably didn't make financial sense. They probably just said, hey, let's just split it 50-50 like we do everywhere. And let's get a pump that pushes enough flow kind of to meet the demand. I just think that my idea of demand is different because, if you've driven construction equipment, if you've driven bigger tractors, having those faster hydraulics are a whole lot better. You work faster, you work more efficiently. Two functions at once, three functions at once from the backhoe's perspective. That just makes it so much more enjoyable. But for, I think, a lot of us, I have an acre of land. My parents have some land that I help with, but I don't need a huge tractor. The big 2 series, the biggest I would ever go is 2025R. Because I don't want to try to store it, and I don't want it to tear up my yard. I want to be able to mow with it if I want to, move sand around, do landscaping, that type of thing. So I think for a lot of us, this is the right size tractor, and it is very capable. We just, it needs that capability unleashed, and that's what we're trying to do here just a little bit. So that's this valve. I hope I'd be interested to see what this video looks like, because I have this set up. If you're interested in this setup, this was we recently got a golden doodle, and I thought I was going to put the dog on here and groom it. The dog's already way bigger than the table, so this has become my hydraulic table. And it actually has this thing that kind of goes up and holds a leash, and that's what's holding my phone at this point. I'm not very sophisticated, I don't have high-end camera equipment here, but I hope this is helpful, and let me know in the comments if it's something that you find interesting. I thought it was interesting. I do think there's a handful of people at least that find it interesting, and this is not a whole lot of effort to make, so I'm happy to do this while I have the parts off, so that you don't have to take your parts off and pull them apart and understand them. I've had this thing apart like 3 or 4 times, so I feel like I know it inside and out at this point. But maybe it'll spur an idea for something that you're trying to do associated with these pieces. I don't know. So Thanks for watching. You know, this is on a new, I just made this new channel simply because I didn't want to mix my personal channel and this channel, or the things that I'm doing here, because I have friends that follow me and they're like, what the hell are you doing with this tractor stuff? It's, you know, they're not going to want to follow along with those things. They want to see my kids. But definitely, you know, subscribe. I'm not going to be spamming people, so subscribe if you want, and don't if you don't want. I don't expect this to be something that's a moneymaker. I'm not planning on monetizing the channel, but I did, when I made the new channel, I learned that you have to have 1,000 subscribers so that you can monetize. I mean, I think my personal channel has like 2,800, and I'm sure most of those are bots. So I could technically monetize that for, you know, tens of dollars probably if I really tried, but no, I'm just kidding. If you have an idea of something that you want to see that you know that I'm playing with right now, let me know, and I'll try to, if this worked out well, I'll try to set it up and show you what I know. All right. Talk to y'all later.